In our previous chapter, we have learned how to import and export data using RStudio. However, there are also special functions in R to import and export very large data effectively and efficiently with better memory management. So let's see what are those. Working with big data. R provides two ways to work with big data. One by using R-Hadoop functions and another is R's inbuilt base packages and functions by using systems RAM. But the problem with the R's inbuilt base functions is that it can handle the amount of data based on systems RAM availability. Therefore, higher system memory provides better performance. One of the common errors related to memory in R will show can't allocate vector size, that is error due to memory limitation. So our developers created special packages and functions to handle big data in R through better memory management. Let's start with R-Hadoop. R-Hadoop is another function to integrate R programming language with Hadoop. Due to its limit of handling data based on systems RAM availability, R uses special packages and functions to send back and forth to process the user's instructions using Hadoop framework. The reason why R-Hadoop is good fit for big data analytics is it is an interactive language used for advanced visualization and can be easily implemented with statistical programming features like predictive analysis. Before you go for R-Hadoop, you need to be familiar with the Hadoop concepts. For that, we have a separate module on in-depth concepts of integrating big data technologies like Hadoop. So follow our Big Data Analytics course to learn and perform analytics on big data. Now, R also has its own special packages and functions to read big data, for example, fread, similar to read.table in terms of functionality, but faster and effective with more parameters for different formats of data. Here, in fread, all the controls such as SEP, column classes, and rows are automatically detected. Integer data types are also detected and read directly without defining any parameters. Dates are read as characters and can be converted afterwards using the time package or any standard R-based functions. So to implement the fread function, type fread, then input is the file name to read, separator is equal to auto, header auto, enabling the rich features of automatic identifier of the fread function. Then comes the nrow is equal to -1l, that is the number of rows to read. By default, -1 means all. Let's compare the fread function with the R-based function. On how much time will it take to read a file? First, using standard R-based function. We have our regular function read.table to read the store.csv with header is equal to true, SEP is equal to comma, fill is equal to true, and lastly number of rows to read is equal to 28,000. Inside another function called system.time. System.time is just a function to display the time taken to execute a line of code. We can say it took 0.5. Now, to use the fread function, we need to install the data table package. Then we will redo the same for the fread function. Here we can clearly observe the difference of 100%, 0.5 to 0.05. To know more about the fread function features, use the question mark fread for the full documentation of the function. Next function to read the big data is read.csv.sql. That reads the file by filtering it with an SQL statement so that it can handle large files in R. All the parameters are mapped to read.csv, except the unique parameter SQL is equal to SQL statements to filter. This time also we'll perform the same exercise like fread function to compare performance of read.csv.sql with the base R function using system.time. Then install the sql.df package for read.csv.sql function. Now read the data from SQL is equal to select star from file where assault greater than equal to 10. The elapsed time, that is the execution time, will show a higher than the regular read.table function. This is because it has an extra filter function to segregate the data. So it is very helpful when it comes to reading a subset of data from millions of rows and columns, where a regular read function fails or it takes a lot of time to read all the million rows and columns. Number 3 is the read.csv.ffdf function that reads the input file into FF data frame objects, very much like using read.csv and read.table, but of course with more effective memory management. Different parameters of read.csv.ffdf includes verbose, which shows timing of each process chunk. Now we again use the same system.time technique to check the performance. Inside the function we have header is equal to true, verbose is equal to true, first rows 40,000 and then next rows 9,000. Okay, let me explain you through the output. It will be more easier to understand. In the output we can observe the verbose, that is the total time to read the first chunk of data, is 1 to 40,000 rows took 0.47 seconds. And for the next chunk it took 0.2 seconds to load the 9,000 rows from 40,001 to 49,000 and so on. So the total time taken, that is our system.time output, is 0.99. The default values to read the first chunk is 1000. And for the subsequent chunks, it adjusts to RAM's availability. To know more about the features of read.table.ffdf, we can always use a question mark ff then read.table.ffdf for the full documentation. To export the big data, we can use our regular base R packages and functions like write.csv, write.table. However, we still have the export function of ffdf, that is read.csv.ffdf, to export the FF data frame into text files. I have gathered 2 common errors that we might encounter while using those functions. One error is in scan. Lines didn't have 5 elements. This is because rows are of unequal length, and the solution to this is to add fill is equal to true to fill it with blank spaces. Second one is the error in FF, vmode character not implemented. We have observed that in our last function we had defined the column classes. This is because it doesn't support character vectors, so it needs to be stored as factors. The disadvantage of this is the levels are stored in the RAM, so if there are large number of levels, it might cause memory problems. Next, we will learn how to import, export and read directly the worksheets of an Excel file.